The overarching conviction among most researchers is that speculations about the universe's starting points continue to be the primary explanation for its early phases. This hypothesis links the formation of stars and planets, which ultimately led to the evolution of life, including mankind itself. Despite its unconventional name, the Big Bang offers detailed insight into what could have occurred at the universe's inception. At first, the universe was compressed into an extraordinarily small space, much smaller than a pinhead with particles densely packed. From this compact state, a massive release of energy and matter, referred to as the Big Bang, occurred. This catastrophic event, which happened billions of years ago, set the universe's extensive history in motion. However, as scientific knowledge advances, discrepancies have emerged, challenging the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, JWST, the most advanced and largest space observatory ever made, experts anticipated its observations would confirm the Big Bang theory. Yet, within just 1 year of operation, the telescope surprised scientists with its extraordinary ability to peer into the distant past of the universe. The JWST's incredible capabilities have revealed galaxies dating back to a time so ancient that it challenges our understanding of the universe's origins. This discovery has sparked a wave of discussions about the potential existence of matter before the Big Bang. One particularly significant development occurred when cosmologist Rohan Natu, examining data from the telescope, discovered a galaxy from soon after the Big Bang, marking it as the farthest galaxy observed to date. This revelation sent shockwaves through the scientific community, highlighting the astounding skills of the James Webb Telescope. The telescope's immense potential to reshape our understanding of the universe is just beginning to be realized, with promising revelations about its earliest stages. This time span, loosely associated with earlier cosmic history, holds the key to understanding the emergence of the first stars and galaxies. The discoveries made by the JWST have challenged established theories, uncovering galaxies with characteristics that defy prior assumptions. This surge of early galaxies has ignited a frenzy of scientific inquiry, pushing experts to reconcile these new findings with existing theories. As researchers continue to explore these discoveries, they face fundamental questions about the nature of the universe and the forces that guided its development. Beyond its remarkable scientific contributions, the JWST is strategically located 1.5 million kilometers from Earth, shielded from interference and cooled to nearly absolute zero by its tennis court-sized sunshield. The telescope is equipped with a massive primary mirror and incredibly sensitive instruments specifically designed to uncover secrets about the early universe that were previously hidden. This early cosmic period, known as the Cosmic Dawn, occurred roughly 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains an intense subject of study, with various theories proposed, such as the roles of dark matter and dark energy or the interactions between star-forming gas and dust. The JWST's ability to observe galaxies from this time provides an exciting opportunity for astronomers to test existing models of the universe. By investigating these ancient galaxies, scientists can either validate current models or identify gaps in our understanding, potentially leading to groundbreaking discoveries. Initially, the JWST was expected to detect only a handful of faint, small galaxies during its early observations. However, the reality far exceeded these expectations. The telescope's first images of the distant universe revealed an abundance of galaxies with diverse ages, sizes, and luminosities, surpassing all prior predictions. This unexpected influx of early galaxies has triggered a race among space scientists to revise the records of the earliest known massive systems. New findings are emerging constantly, leaving even seasoned researchers in awe. Following the JWST revelations, both experts and the public have been eager to analyze the presence of these highly advanced early systems. Some theorists propose that errors in how the telescope interprets large-scale observations could account for these astonishing discoveries. However, the consensus remains that these revelations represent a paradigm shift in how we view the early universe and offer an intriguing glimpse into the potential for significant change in our understanding. The new discoveries about early galaxies, made possible by the JWST, have raised profound questions about the universe's nature and challenged the assumptions of conventional cosmological models. While some experts are exploring whether these findings can be integrated into existing theories, others suggest that these revelations may be the first signs of a universe far more complex and mysterious than previously imagined. The fundamental question remains: how did the universe we know today arise from the chaotic turmoil of its early stages? The JWST's early discoveries could radically reshape our understanding of the Big Bang and offer new insights, not just into distant galaxies and ancient cosmic structures, but also into the very makeup of our own Milky Way galaxy. As Mark McFadden, a senior scientist for science and exploration at the European Space Agency, aptly stated, "You build these machines not to confirm theories but to break them. You just have no idea how it will break." The origins of the JWST date back to 1985 at the Space Telescope Science Institute, STSCI, long before the launch of the Hubble Space Telescope. At that time, Garth Weir, then the director of STSCI, was tasked with envisioning what might come after Hubble. Despite initial skepticism, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily observes visible light, the JWST was designed to see in the infrared spectrum, allowing it to peer deeper into the universe. This infrared capability is critical for studying distant galaxies, whose light has been stretched into the infrared due to the universe's expansion, rendering them invisible to telescopes like Hubble. With its large, cold, star-like mirror, the JWST has become an essential tool for unlocking the secrets of the cosmic dawn. The need for the JWST became clear in 1995 when the Hubble Deep Field Observation revealed an immense number of galaxies in a previously thought empty patch of sky. This discovery demonstrated the richness of the early universe and highlighted the need for a more powerful telescope capable of observing even further back in time. After decades of development and an investment of around $1 billion, the JWST was launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Programs like the Early Release Science (ERS) and the General Observing Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. The JWST observations have tested existing models of the early universe, uncovering galaxies that challenge traditional cosmological assumptions. These extraordinary discoveries underscore the importance of pushing These emerging inconsistencies have fueled debates among scientists, prompting a re-evaluation of long-held theories about the universe's origin. With every new observation made by the James Webb Space Telescope (JWST), the boundaries of our understanding are being pushed further, revealing a cosmos that is both more complex and more mysterious than previously imagined. One of the most groundbreaking aspects of the JWST is its ability to capture light from the earliest galaxies, formed just a few 100 million years after the Big Bang. These galaxies challenge existing models of cosmology, particularly those related to galaxy formation and evolution. For instance, the discovery of large, mature galaxies in these early epochs raises questions about how such massive structures could have formed so quickly after the universe began. These findings suggest that either our current understanding of cosmic timelines is incomplete or that new, unforeseen mechanisms played a role in the early universe. Some researchers propose that interactions between dark matter and ordinary matter, as well as unknown properties of the first stars, may hold the key to solving these puzzles. Others speculate that entirely new physics could be required to explain the observations. The implications of these discoveries extend beyond astrophysics. They challenge the very foundation of cosmology, urging scientists to reconsider fundamental concepts such as the nature of time, the structure of space, and the role of dark energy and dark matter in shaping the universe. The JWST's ability to observe galaxies at unprecedented distances also opens the door to studying the chemical composition of early stars, which could provide clues about the origins of elements essential for life. As the JWST continues its mission, the scientific community is eagerly awaiting more data to either confirm or refute the surprising initial findings. Each new observation has the potential to rewrite textbooks, offering a deeper and more nuanced understanding of the cosmos. These discoveries also highlight the importance of international collaboration and cutting-edge technology in advancing human knowledge. Looking ahead, the JWST is poised to explore additional mysteries, such as the formation of supermassive black holes, the role of cosmic filaments in galaxy clustering, and the potential for habitability in exoplanetary systems. By combining its infrared capabilities with the expertise of scientists worldwide, the telescope will likely uncover answers to some of the most profound questions about the universe, and perhaps raise even more questions in the process. Ultimately, the James Webb Space Telescope represents a new era in astronomy, one defined by unprecedented precision and transformative discoveries. Its findings remind us of the boundless potential of science to challenge assumptions, illuminate the unknown, and inspire generations to continue exploring the universe's greatest mysteries. The observatory, at any point fabricated, was expected by researchers to approve the hypothesis of the universe's starting point. Sadly, within just 1 year of activity, the telescope surprised specialists with its capacity to peer so deeply into the past of the universe. The amazing force of the JWST has uncovered universes that date back to a time so old that it forces us to re-evaluate our current comprehension of the universe's arrangement. This shocking revelation has ignited a heated discussion about what may have existed before the Big Bang. One advancement came when cosmologist Rohan Natu, working with data from the telescope, distinguished a universe from merely a brief time frame after the enormous detonation, making it the most far-off system ever observed. This discovery sent shockwaves throughout the scientific community, highlighting the incredible capabilities of the James Webb Space Telescope, JWST. The telescope's vast potential to transform how we view the universe is just beginning to unfold. It promises to provide significant insights into the earliest moments of the universe's existence, a time span that loosely aligns with earlier cosmological theories. Understanding this period is essential to learning how the first stars and galaxies emerged. The discoveries made by the JWST have challenged conventional models, revealing galaxies with characteristics that surpass previous expectations. This influx of early galaxies has sparked a surge of scientific investigation, pushing researchers to reconcile these new discoveries with existing theories. As analysts examine these findings, they face critical questions about the fundamental nature of the universe and the forces that guided its evolution. Notwithstanding its remarkable scientific contributions, the JWST is strategically located 1.5 million kilometers from Earth, where it is shielded from interference and kept cool by a sunshield the size of a tennis court. This allows the telescope to observe the universe without the distortion of Earth's atmosphere. Equipped with a massive primary mirror and delicate instruments, the JWST is designed to capture extraordinary details of the early universe. This era, known as the Great Dawn, occurred between 230 and 300 million years after the Big Bang, when the first stars and galaxies began to form. The mechanisms behind this process remain an area of intense study, involving theories about dark matter, dark energy, and the interplay between star-forming gas and dust. The telescope's ability to observe galaxies from this critical period gives cosmologists an unprecedented opportunity to test their models of the early universe. By examining these ancient galaxies, researchers can either confirm the accuracy of current theories or identify gaps in our understanding that could lead to groundbreaking insights. Initially, researchers predicted that the JWST would uncover only a few faint, small galaxies during its early observations. However, reality far exceeded these expectations. The telescope's first images of the distant universe revealed a staggering number of galaxies, some with ages, sizes, and brightness levels that defy previous models. This unexpected surge of early galaxies has sparked a race among researchers to set new records for the earliest known massive systems, with discoveries emerging continually. Even seasoned astronomers have been left in awe as the JWST continues to uncover more about these early universes. Both experts and the general public have become increasingly focused on the telescope's advanced capabilities. Some specialists have raised the possibility that the telescope's interpretation of large-scale observations might explain some of these remarkable discoveries. However, the general consensus remains that these revelations mark a paradigm shift in our understanding of the early universe, offering exciting possibilities for future discoveries. The new findings from the JWST have raised profound questions about the nature of the universe, challenging assumptions of traditional cosmological models. While some researchers are investigating whether these discoveries can be reconciled with current theories, others suggest they may hint at a more complex and perplexing universe than previously imagined. The key question remains: how did the universe we know today emerge from the primordial chaos of its early stages? The JWST's early findings could revolutionize our understanding of the Big Bang and provide insights not only into distant galaxies and ancient structures but also into the fundamental nature of our own Milky Way galaxy. As Mark McFadden, senior researcher for science and investigation at the European Space Agency, remarked, "You build these machines not to confirm theories but to break them. You have no idea how it will break." The origins of the JWST trace back to 1985 at the Space Telescope Science Institute, STSCI, long before the Hubble Space Telescope was launched. At that time, Gene Weir, the head of STSCI, was tasked with conceptualizing what could succeed Hubble. Despite initial doubts, Weir and a small team laid the foundation for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily observes visible light, the JWST was designed to see in the infrared spectrum, enabling it to look deeper into the universe. This infrared capability is essential for studying distant galaxies, whose light has been stretched into the infrared due to the expansion of the universe, rendering them invisible to telescopes like Hubble. The JWST became an essential tool for unlocking the mysteries of the Great Dawn. The need for such a telescope became evident in 1995 when Hubble's deep field observation revealed countless galaxies in what was once thought to be an empty patch of sky. This discovery highlighted the richness of the early universe and underscored the necessity for a telescope capable of probing deeper into the cosmos. After years of development and an estimated cost of around $1 billion, the JWST was successfully launched on December 25, 2021. By July 2022, it was ready to begin its critical year of scientific observations. Programs like the Early Release Science (ERS) and the General Observing Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. The JWST observations have already challenged existing models of the early universe, revealing galaxies that defy conventional cosmological assumptions. These groundbreaking discoveries underscore the importance of pushing the boundaries of scientific exploration and showcase the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to analyze data from the JWST, new insights may emerge that further test and broaden our understanding of the universe. When the first data began to arrive from the JWST, cosmologists eagerly awaited the results, many having spent years preparing their data analysis systems for this moment. Instead of adhering to the traditional peer review process, which can take months, researchers opted to share their findings on preprint servers such as AR14, where papers can be accessed publicly before peer review. This approach facilitated rapid discussions among experts, particularly on online platforms like Twitter. Rohan Nata referred to this process as science by press release, and the ensuing wave of online discussion was both intense and unprecedented. Despite these challenges, the rapid sharing of findings has also fostered collaboration and innovation. The JWST's data has inspired a global effort among scientists to re-examine the early stages of the universe. Researchers are now analyzing faint, ancient light from galaxies formed billions of years ago, testing hypotheses about their structure, evolution, and interaction. One of the most surprising discoveries has been the identification of galaxies that appear far more mature than previously expected so soon after the Big Bang. Some of these galaxies are massive, showing features such as spiral arms, which conventional models predicted would take much longer to develop. This raises questions about the timeline of galaxy formation and evolution. In addition to galaxies, the JWST has also provided unparalleled insights into other cosmic phenomena, including the composition of exoplanetary atmospheres, star-forming regions, and interstellar dust. By analyzing the light spectra captured by the telescope, researchers can determine the chemical makeup of these distant objects, shedding light on the processes that shape the universe. Moreover, the telescope's ability to peer through clouds of dust and gas has unveiled new details about the birth of stars and planetary systems. These observations help researchers understand how our own solar system may have formed and offer clues about the potential for life elsewhere in the universe. A new era in astronomy. As the James Webb Space Telescope continues its mission, its discoveries are redefining our understanding of the cosmos. Each observation challenges long-held theories and opens new avenues for exploration. The telescope's success demonstrates the value of decades of investment in cutting-edge technology and international collaboration. The JWST's achievements highlight humanity's capacity to seek answers to the universe's most profound questions. By pushing the boundaries of what is observable, the telescope inspires not only scientists but also the broader public to marvel at the vastness and complexity of the cosmos. Looking ahead, the James Webb Space Telescope is expected to continue revolutionizing astronomy for years to come. Its findings will likely lead to the refinement of existing theories and the development of entirely new models of the universe's origin and evolution. The questions it raises, about the nature of dark matter, dark energy, and the forces that shape the early universe, will guide the next generation of researchers as they strive to uncover the secrets of the cosmos. Closing thoughts. In the words of John Mather, a senior scientist on the JWST project, we are looking at the universe like never before. The Webb telescope is not just a tool for science, it's a time machine that allows us to see back to the beginning of everything. What we're learning is that the universe is far more mysterious and fascinating than we ever imagined. As we stand on the cusp of this new era in astronomy, the James Webb Space Telescope serves as a testament to human ingenuity, perseverance, and our unyielding curiosity about the universe we call home.